Okay, in this video, we are going to learn about a matrix formula for the dot product in a vectors. So, do you guys know, actually we also can find the dot product of vectors in matrix form. First of all, vector in our power of n, u bar equals to u1, u2, un can written as column matrix. The question is how to change the vector into the matrix form. First of all, to change the vector into the matrix form, we have to see that each components of the vectors has to be in different row. For example, I will give you some example here, which is u bar equals to 3, 1, 2. To change it into the matrix form, we just need to put the 3, 1 and 2 into the different rows of the matrix. As we can see here, 3 would be in the row 1, 1 will be in the row 2, and 2 will be in the third row. So as you can see here, this is the way to change the vector into the matrix form. So the question is how to find the dot product in matrix form. Let me read this question first again. How to find Euclidean inner product of vectors in matrix form. To find inner product of vectors in matrix form, here is the formula that we have to follow, which is u bar dot v bar equals to u bar transpose with v bar, or we also can use the formula v transpose u bar. So here is the example of two vectors that we have. First, u bar equals to 7, 1, 2. V bar equals to 8, 3, 4. Our very first step is we have to change the vectors into matrix form. So, like I said to you guys previously, we just need to change the 7, 1 and 2 into the different rows. And so goes to this one. And based on this formula, if we choose this formula, we need to have u transpose. So how to find the u transpose? To find the u transpose, we just need to change all of the numbers, all of the entries in this row into the row. I mean all of this column into the row, like this, which is 7 into this one, and 1 into this, and 2 into this. And for v, we just stick to this. We don't need to change it to the transpose based on this formula. So as we already have u transpose and v bar, we just need to apply this formula like this one, which is u transpose equals to 7, 1, 2 and v bar equals to 8, 3, 4. So to solve this matrix, we just need to do is as usual, which is 7 multiplied with 8, 1 multiplied with 3, and 2 multiplied with 4, which it will be in this form. And then we just need to calculate it, and we will get 1667. So that is the basics on how to find the Euclidean inner product of vectors in the matrix form. And as you guys have to know, you need to remember the formula to find the Euclidean inner product in matrix form, which is u bar dot v bar equals to u bar transpose v bar. Or we also can use this formula, which is v bar transpose and u bar. So the next part is, what is the difference between dot product of vectors in matrix form and multiplication of matrices? If we want to find the difference, of course, I have to give you some examples so that you guys can understand it easily. So here, as we can see, there is two vectors and I change it into this form, which is matrix form, to apply with this formula, and then we get this answer. And the next one is, we got two matrices and I multiplied it and we will get it in this form of answer. So as we can see here, there are few differences between these two operations. For the first difference that we can see is, what is the purpose of each operation? For the first one, as we can see, the purpose that we want to get dot product of vectors in matrix form is to find the angles, and we also can use this to find the distance or length of the vectors. And this operation of multiplication of matrices, the purpose is to get the new matrices by getting the multiplication of matrices. The next difference of these two operations is the formula that we use for each operation. So as we can see here, to get the dot product of vectors in matrix form, we need to use this formula, which is u bar dot v bar equals to u bar transpose v bar. So we have to change it in this kind of form. And based on this operation, we don't need to find any transpose of matrix. Instead, we just need to multiply each of these entries. So that is the difference, second difference. And the next difference that we can find obviously is the answer. We can see here that there are differences between these two answers. And for this operation, the answer will always be a real number, which is 119. And the next one, we can see that the answer is in matrix form, which is a new matrix form because of this multiplication of matrices. So obviously we can find here there are three differences that we can find for this operation. Perhaps maybe you guys can find another differences of this operation. So that's all we are going to learn about in this video. Thank you for watching.